Hey everyone! Today, I got an idea from a tin can, and it's going to be a key part of our homemade antenna. Let's get to it. Here I have a spark plug, which will carry the signal from the antenna rod to the coaxial cable. To do that, we'll fix its threaded part right in the center of the tin can. So the next step is to drill a perfectly sized hole in the middle of the can's bottom. It looks like I drilled a bit too much, so the hole ended up slightly larger than planned. But no worries, we can still secure the spark plug firmly later. The next step is to tidy up the hole and make it flat. I'll use some sandpaper or a light filing tool to smooth out the rough edges, making the hole neat and just the right fit for the spark plug's threaded part. This step is important because when we install the plug, it won't tilt, and the signal from the antenna rod to the coaxial cable will remain stable. Once the hole is properly prepared, fixing the spark plug will be much easier, and the device will work more efficiently. I'm going to drill a small extra hole at the bottom of the can to make connections easier. I'm going to attach a bolt and nut set to the small hole we just drilled, making the next connection step easier and more secure. This tin can lid already has a small hole drilled in it. Now, we're going to turn it into an antenna rod to receive signals by attaching it to the spark plug's threaded end. Here I have a piece of coaxial cable, but this isn't the usual step of just connecting wires. This step is a bit more precise. I'll be separating the inner copper core to turn it into the main antenna rod for receiving signals. First, I carefully strip off the outer insulation and the braided shield, leaving only the central copper core. This core will then be shaped or positioned to maximize signal reception while avoiding contact with any other metal parts. This step is crucial because the main antenna rod determines the overall performance of the device's signal reception. The antenna element I want to shape is going to be a spiral. I'll bend the copper wire following the same twist pattern as a step drill bit, basically tracing its spiral direction. This spiral form gives the antenna a more stable structure and lines it up with the direction of signal reception I'm aiming for. The way I attach this spiral antenna element to the spark plug connector is more about positioning than anything complicated. I let the tip of the spiral make contact at the connection point, while the base of the spiral is oriented upward to help with signal pickup. The idea is just to create a stable contact at the bottom and let the spiral rise like a small signal-catching tower. This arrangement allows the antenna to receive signals more naturally without needing to alter the spark plug or any other component. For this wiring step, I prepare a longer piece of coaxial cable. One end goes toward the grounding point of the spark plug to create a stable reference for the setup. The other end gets fitted with an inline F connector and a 90-degree F connector, making it easier to route and position the cable cleanly. The goal here isn't anything complicated, just making sure the cable runs in the right direction and stays firmly in place, so the signal path remains steady. To keep things safe when dealing with electrical connections, I wrap a layer of electrical tape around the joint. It covers the exposed area and reduces the risk of short circuits or any unwanted contact while the setup is running. It's a small step, but adds a lot of peace of mind. On this end of the coaxial cable, the metal braid is brought over to the bolt to act as the common contact point. The idea is simply to use that braided layer as a stable connection path, giving the whole setup a shared reference point during operation. This way everything stays neat, and the connection remains steady and reliable. Of course, an antenna base is something we can't leave out. You can get creative and make any style of base that works with the materials you have. And if you're out of ideas, feel free to take inspiration from the one I'm putting together here. The main point is just to have a sturdy base that keeps the antenna steady. Everything else is totally up to your own creativity. And that's it. Now I'm going to take it out and test it right away. Take a close look. Right now, I haven't connected the antenna to the TV yet, so the screen still says no signal. Don't get ahead of yourself. I just want to show that the whole process is completely transparent, and I'm not faking any results before hooking the device up to the TV. In just about 3 seconds, the screen already shows a signal. But we're not jumping to conclusions yet. We'll wait a bit longer to see if the signal stays stable. It's a careful way to check, making sure everything really works and isn't just a temporary spike. I've been switching channels continuously and waiting for a while, and nothing adverse has happened so far. So now I'm going to unplug the cable and plug it back in to see if the signal remains as stable as it was before. This is just a thorough way to make sure the results aren't just a temporary fluke. I can conclude that it's a success. After all the testing, the signal stayed stable, the channels came in clearly, and everything worked exactly as expected. Even when I tried unplugging and plugging the cable back in or switching channels repeatedly, the setup maintained the same performance. This process shows that with a bit of creativity and patience, you can build an effective antenna yourself. I hope this video inspires you to experiment and explore new ideas of your own.